And we are live. Okay, so I'm holding the dog, but for a better reason than usual, I'm trying to make it so that you can see her eyes. See, I keep on having to rotate the dog because she seems magnetically repelled by the camera. She just always turns her head. But anyway, I do this because I've always found it really cute that her eyes are so round. Now you might think, lie down instead. You might think, eyes are round. Yeah, human eyes are round, but not really. If we really look at our eyes, they're not really that close to being round. Hers are closer to being perfectly round than a human's eyes, that's for sure. So since we're doing circle geometry, I thought that I would measure the diameter of Mocha's eyes, and we can calculate the radius and the circumference and the area of her eyes, just as our first problem. So I'm doing sort of circle word problems, although this one I'm not writing down the problem. I'll write down the others, which means I have to spend some time writing on the chalkboard, and that reduces how many examples I can do during the lesson. But so be it, word problems matter, so we have to take the time to practice them sometimes. So today all we're doing is word problems involving circles. And I'm trying not to involve anything else. I'm refusing to involve a certain type of round food that I normally like to eat and talk about all the time, so I don't even want to mention its name. But I do have this square, so sorry, but we also have to be aware of how squares work and be able to use the area of a square formula in order to answer this question. But this is for later. I drew it ahead of time because I knew it would take a while to draw. So I'm Doug, welcome to Math with Doug. Mocha's down there. It's starting to be springtime and I'm starting to get into quite a good mood. There has been a lot of melting, drip, drip, drip everywhere today, and I'm happy about it because I know that I'm going to be able to get outside and do a lot more good stuff with my woodworking hobby and gardening and all sorts of good news that starts happening at this time of year. I'm very happy about it. I complain about winter all the time, but I actually do like to ski, and I haven't gone skiing lately. I think I'm going to have to make a pledge, and I'm telling you right now, next year I'm going skiing so that I can enjoy winter and not be complaining about it and waiting for it to be over the whole season like I was this year. Finally, he will start talking about some math after he points out that this is a Columbia national team soccer jersey. And I might have to, if I have time at the end and I need another problem, I might have to measure the radius, diameter, circumference, and area of that patch because it's round. I'm just noticing that now. Okay, so we're starting with Mocha's eye. And her eye, I measured it best I could. I didn't really want to press the ruler into her eye. Her eye, I believe, the diameter of her eye is 1/2 inch. So, diameter equals 1/2 inch. Now, of course, we could do this in decimal. We could say it's 0.5 inches, but I'm not afraid of fractions. Are you? Okay, so let's find the radius. The radius is going to be the diameter divided by 2. So that's going to be 1/2 inches. I don't really have to show the inches symbol. Divided by 2, which is this all going to fit? Yes, it is. 1/4 inch radius for Mocha's eyes. That quick. Once you get into your circle geometry, you get so that you're using these little formulas very quickly, and that's good. That's what happens with practice. The circumference of Mocha's eyes, I have 2 different formulas that I can use. I'll remind you of that, but I'm just going to use one of them. I feel like using the pi d version of the formula. So that is pi times the diameter, which is 3.14. Yes, in today's lesson we are using 3.14 for pi, times the diameter, which is the 1/2. Oh, now he's mixing decimals and fractions in the same multiplication. No problem. Okay, so it's going to be 3.14 divided by 2, or 3.14 times 1/2, which is the same thing. And I'll get my calculator, my dusty, chalk dusty calculator. 3.14 times 1/2, 1.57. I don't suppose that will surprise too many people. 1.57 inches. I do not choose to express that as a fraction. 1/2 inch diameter 1.5, just a little bit more than 3/2 inches. Yeah, a little bit more than 3. Remind us of anything? Yes. Okay, so we are feeling comfortable with these formulas, and that's good. Of course, c equals 2 pi r would have given us the same answer. And now we are going to do the area. The area is pi r squared, which I will show, pi r squared, which will be 3.14, and then the r is the 1/4 squared. Okay, and of course we have to follow the order of operations, so 1/4 squared has to be done first. And then we multiply that by pi times 3.14, and we get an area of 0.19625. It only goes to that many decimal places, so I'm just going to write down the whole thing. 0.19625. And that is going to be inches squared because it is area. Is it a perfect exact value because of the fact that I chose not to round the answer that was in my calculator? No, because I did round when I chose to use 3.14 for pi. So the area of Mocha's eye, one of her eyes, is very close to 0.19625 square inches. And there we have done our first problem of the day, finding out all sorts of unnecessary detail about this dog. Okay, let's erase. I'm going to take a sip of my fizzy water. Remember, always, when you're learning math, make sure you have water or some other useful refreshment handy, because learning math dehydrates us. It makes our bodies work, because our brains are, when your brain is working, your body is working. And that makes your body use up water, and then you need to replenish it. This is lime, no, not lime, it is lemon flavored fizzy water. Okay, next, I'm not going to do this one yet. It's, let me think here, where did I put that one? Oh yeah, that's actually the fourth problem that I put together for this lesson, so maybe I'll get to it with the fourth, or I might just get tired of it being here in the way and decide to do it earlier. But I'm going to erase the Mocha's eye problem. And I think I'm going to put c equals pi d here. I'm not writing it in very large lettering, but just a reminder, c equals 2 pi r, a equals pi r squared, and they're sort of out of the way, so I'll just leave them there for the whole lesson, and everything's fitting nicely. It seems like wide-angle-y, this lesson, although I have to be careful not to write too small and make it hard for people to see on the video. And then, of course, the diameter is equal to 2 times the radius, which really is a formula, although people like to do it in their heads. And the radius is equal to the diameter divided by 2, which is really the same formula. So those are sitting there, and we'll try to remember to keep them there. I'll try to remember not to erase them. And we will do some more problems. So the next problem, and then I have a space issue, because I'd like to be able to write the word problem here, but I can't. I have this in the way. I have to leave room to do the calculation. And I even need a diagram. That's an interesting thing to talk about. Word problems when you're doing geometry. Are they really word problems? Because very frequently, when you're doing word problems in geometry, the word problem is accompanied by a diagram. And the diagram can be extremely helpful. Word problems in geometry where they don't give you a diagram, the best thing is to draw one. And that's a really good idea. But if they give you a diagram, then you can draw right on it as you're solving the problem. Very helpful. So it's not really all about the words. I'm just wiping off excess chalk dust because the amount of it was starting to be embarrassing. Okay, I'm going to draw a circle which is representing one that I intend to make out of wood. So it's an art project. So I'm going to make a wooden circle. And although I'm not trying to draw it at the exact size, I am going to give you the information that the diameter of this, a little bigger, the diameter of this wooden circle is going to be 28 inches. And then inside that, what I'm going to do is I am going to cut out from the wood a smaller circle. And I'll sort of draw that freehand. The smaller circle that I'm going to cut out is going to have a diameter, oh no, a radius of 7 inches. Okay, I had to write that pretty small. How is it going to look on the video? And I don't really have any room for writing all of the words for my word problem. I think I'm going to try to write them here. Yes, I do have some useful bit of room there. So I want to write as little as possible. So I made a circle from wood with a 28-inch diameter and then cut out of it a circle with a 7-inch radius. So I'll just say that out loud and the rest of it I'll write. If I line the edges, all of the edges, with gold wire, gold, or at least gold colored wire, gold wire, how much wire do I need, or how long a wire will I need? So there's my abbreviated word problem, and this experience, oh, it looks all crooked. It's not crooked, it looks crooked. And this experience is teaching me that after I do this wooden circles problem, I'm going to do this one next so that I can erase it and have more room afterwards. Okay, how long a piece of wire will I need? So to understand the problem, that's the issue with word problems. There are different levels of understanding. Reading it more than once always helps. So I always recommend to students, read it more than once. The first time you read it, it might seem like too much information and you're not sure what to do. But then the second time you read it, you realize that there's parts of it that you already understand and you're focusing on bits of it that you don't necessarily fully understand yet, and you just narrow it down, and the more times you read it, the more clear it is what you have to do. So that is one of the things to do for students who struggle with word problems. Read them more than once. Don't panic the first time you read it. But then there's this issue of translation. We have to translate the information and the words into math language, which tends to be very numbery and equation-y and formula-y. But there's also the issue of what is it they mean? Did the person who wrote the word problem explain it clearly enough so that I can understand it? There occasionally have been word problems that were not written very well, and it was hard for these students to understand what was wanted. But let's remind ourselves what's happening here. We're imagining this is a piece of wood with the 28-inch diameter. And then I have cut a hole out of it, which is also a circle. So the 28-inch circle of wood has a hole, which is also a circle cut out of it. And that hole has a 7-inch radius. I'm lining all of the edges with wire, which means I'm putting wire all the way around the edge of this little circle, because that's where there's an edge to the wood, because there's no wood in there. But I'm also lining all of the edge of the big circle with wood, because that's also the edge. So I realize what I need is to find the total circumference of these two circles. If I find the circumference of both of them and then add them together, I am going to have the answer to my question. So sometimes it's not so obvious what they really want when you first read the word problem. Reading it more than once helps you to figure it out. Okay, so I need to do the circumference formula twice. One of them I have a diameter, the other I have a radius, so I'm going to use both versions of this circumference formula. I choose to. Doing the bigger one first. C equals pi d, because I know the diameter of the big circle, which is 3.14 times 28. And I can use my calculator, or I may have already done this and written it down on a piece of paper, which is equal to 87.92. And that's going to be inches. Circumference is in inches. It's not square inches. This is not area. And it has to be inches because the diameter they gave me to start with was in inches. So the information is there. Okay, now we do it again. The circumference, but this time I'm using circumference equals 2 pi r. Because for the smaller circle, they gave me the radius. Now, of course, I know how I can very quickly turn that 7-inch radius using one of these into a 14-inch diameter, and I could use this version of the formula if I want. But I like using both versions of the formula so that I practice both of them. So we have 2 times pi, which is 3.14, times the radius, which is the 7, and that is giving me 43.96 inches. Now all I have to do is add together these two circumferences and it will tell me how much wire I need altogether for my art project. So 87.92 plus 43.96. Of course I can do this with a calculator if I want, but I can also practice my adding of decimals. 2 plus 6 equals 8, 9 plus 9 is 18, that's an 8, carry the 1, 7 plus 3 is 10 plus the 1 I carried is 11, so I'm putting a 1 and carrying a 1. 8 plus 4 is 12, plus the 1 I carried is 13. I have 131.88. Does that match what I did before? Yes, it does. So I feel confident. Inches of wire. And we have successfully solved this word problem. Okay, not such a tough one, but a little bit of a weird situation. You have to take your time when you're reading it to figure out what is it they want? Where are they putting wire? That's the sort of questions that will go in your head, and you have to figure out the answers to them the best you can. If you're really reading a word problem and you really feel like you're not sure what the problem is asking for, I guess the best thing to do is to just start solving everything you can think of, and maybe give them more information than they asked for, and hopefully whatever they really wanted is something that you provided. Let's face it, these are circles. There's only so many things that we can do with the circle at this level of geometry. I could find the area of these if I wasn't sure. I could find the area and also have that on my page somewhere. But to answer this question, we did not need the area. And one of the things that we are testing is whether students realize when they need area and when they need circumference. That's one of the things that we are exercising. That's one of the muscles in our brains that we're exercising when we do word problems about circles. Okay, so I'm going to erase this now. All of this, not the formulas. So carefully avoiding erasing the radius diameter formulas. That's the whole answer. And now I have to manage to write the question that goes with this diagram and still leave myself enough room to solve the problem. Okay. Oh, fortunately, the words in this word problem are not very long. Where can I put this? I think I might be able to fit it right over here. Yes, I can't fit myself over here, but I can fit some words. What is the area of the shaded region? That's an H. It's a messy H, but it's an H. Shaded region. And there was an if. It's important to say this. If the 4 circles are congruent. Now, when I made up this question, I then immediately solved it. And I made a mistake. And I sat there looking at it for about 20 minutes, saying, what have I done wrong? My answer doesn't make sense. What have I done wrong? And I decided, well, actually, I should just confess to that right now, because that's the sort of situation students can be in when they're trying to solve a problem. So a student might make the same mistake as me. So I'll just confess when I get to the mistake. Okay. So we want the area. It's the area of the shaded region. Okay, what do we have here? We have a square, because the 4 circles are congruent. So that means that the width of this circle is equal to the width of that one. And of course, circles, a diameter in this direction has to be equal to a diameter in that direction. So therefore, diameter plus other diameter tells me the length of this rectangle. And then diameter plus other diameter tells me the width or height of the rectangle. but those have to be equal to each other because two diameters of these two circles have to be equal to these two diameters of the circles, because it said the four circles are congruent. If it didn't say that, it might not be so clear what they want. What's the area of the shaded region? That's weird. So it's the area of all of this square that doesn't have circles on it. We're going to have to do a subtraction. The area of the shaded region type of geometry problem frequently will involve subtraction. Okay, and we have the radius of 20. It doesn't say if it's 20 centimeters or 20 inches. I'm just going to, well, what is my, it's inches. So I'll put the little symbol for inches there. So we didn't need much room for the word problem part. We took a lot of room for the diagram part. What we need to do is find the area of one of these circles. And then, of course, it's going to be equal to the area of the other three. And we're going to have to remember the area of a square formula. Sorry, I know I promised circle geometry, so let's call it circle and square geometry just for a second. But, you know, square geometry isn't the most challenging one, so I hope no one minds. The area of one of these circles, that's the area formula, area equals pi r squared, which in this case is equal to 3.14 times 20 squared. And 20 squared is 400, so it's 3.14 times 400. Can I do this in my head? 3.14 times 100 would be 314, and that would eliminate the decimal. That's handy. But then I'd have to multiply it by 4. What's 314 times 4? 1,256. So I have 1,256 square inches. And this is where I made my mistake when I was doing this the first time. I didn't realize for quite a while. I have to multiply that by 4 because there are 4 circles. That was a silly mistake. Times 4 equals, can I do this in my head? 1,200 times 4 is 4,800. 50 times 4 is 200, and 4,800 plus 200 is 5,000. But then I have to do the 4 times 6, so 24. 5,024. 5,024 square inches is the total area of the 4 white circles. Double checking with his notes. There it is. And then we go back to what we were talking about earlier, about how we realized this had to be a square, because it never even said it was a square in the word problem. But that's okay, because that's on purpose, because we have enough information to realize it must be a square. Because the diameter of this circle is going to be 40. Now I am doing the diameter radius formula. So d equals 2r, which in this case is 2 times 20 equals 40 inches. The diameter is 40 inches. And then this one also has to have a diameter of 40 inches, and 40 inches plus 40 inches is 80 inches. So the side length of the square is 80 inches. And of course, I still know it's a square because the same thing's happening in this direction. The diameter of this one has to be 40, plus that one, which is also 40, is 80. So therefore, this side is also 80 inches. And I have a square, and it is fair. Now, how do I should write down everything I do. Always show your work. So where am I going to put that? What will I say? I can just say d times 2 equals 20 times 2 equals 40. I kind of did that over here, so I didn't need to do that. I'm going to erase that instead. No, it's not d times 2 anyway. I'm getting confused. So let me just start over and say what I just said over again. D times 2 is right. D times 2 is equal to 40. I figured out that the d was 40. Don't need the 20. Is equal to 40 times 2 equals 80. Have I given enough information to explain how I know that the side length of this square is 80? I could even write a paragraph. I know the side length of the square has to be 80 inches because, I write all this, and I can also say, I know it has to be a square because I already answered all of that, but it would take a while to write the paragraph. So justifying what you're doing in a geometry problem can take a bit of time, and it can take a bit of writing sometimes. Let's move on and finish this. So the area of a square is equal to side length squared, which is 80 inches squared, which is 6,400 inches squared. And I got a chalk. Finally, to give the area of the shaded region, I have to subtract 6,400 minus 5,024 equals 1376. 1376 inches squared. And now I will double check. Yes, 1376 square inches. Use calculator as necessary. Let's face it, this teacher is a bit of a show-off when he does things in his head, but this teacher also created and solved this problem just a couple of hours ago. So, I remember. Okay, we have done this one, and now we can erase. So the best news is, yay, I can erase and then I have more room, but that's a word problem. It's a geometry style word problem where an awful lot of the information is really in the diagram, and it can make the paragraph part not quite as long. But we're still practicing our word problem skills. And after all the time it took me to draw that beautiful diagram, there it goes. Okay. Back to the originally planned sequence of word problems. How am I doing for time? It's already been 26 minutes. I'm going to have to pick up the pace a little bit. But we've already done 3 if we include the mocha eye problem. And remember, besides hydrating, stretch. Stretch. Hard work doing math. Okay. Another diagram that doesn't really look that different from the first one. So I'm going to trace this thing to make a circle again. Let's get way over here so we have lots of room. So there's a circle. Fast way of drawing a circle. Trace something that's round. And we're finding the shaded area again. So I'm going to draw a smaller circle on this one. It's not the same wooden sculpture problem. I'm going to draw now to get the diagram to look nice. The diameter of this is supposed to be 60 inches. And the radius of this little circle is supposed to be 10 inches. So therefore, maybe that's about good. So I'm just going, I'll write a 10 here. I'm not going to put the inches symbol because that 10 is small enough to start with. Over here, I'm just going to say D equals 60 inches. And I can put this thing down, and I can erase this and make it a little bit more legible. Okay. Find the shaded area. So that's not really a word problem. I don't know. I meant to create word problems. So that means I have to make up a situation for this. Find the shaded area, and the shaded area is the area of the big circle, but the small circle is not shaded. Whew. Find the shaded area which represents the surface of the water in a swimming pool, a round swimming pool, no, 60-inch diameter, that's not a swimming pool. Which represents, what's a 60-inch diameter? That's 5 feet. What circle would be 5 feet? It represents the surface area of the water in a very small round jacuzzi. Tiny little one. But not counting the surface of this round floaty toy that's on it. I'm really making up a lame word problem scenario to go with this, so I think I'm just going to backtrack and say find the shaded area. Not too many words, but let's do the problem. We have to do something quite similar to that first one that looked almost the same. Remember the wire? But the wire was on the edges, and that's circumference. This is about area, and that's really part of what we're doing is just remembering when to use which formula. So I need the area formula. I can do the area of this one right away, so I will. Area equals pi r squared, which is 3.14 times 10 squared. but 10 squared is 100. So it's 3.14 times 100. So we get this lovely 314, and we don't have any decimals. That is inches. I didn't write the inches here, but the inches there. This problem is done in inches. So this is inches squared. This one we have an extra step because we know the diameter, and we're doing the area formula where we have to use the radius. So the radius is equal to diameter over 2, which in this case is 60 over 2, which is 30. And yes, a lot of students really want to just do that in their head and plunk down a 30 into the area formula like this. But those students risk having a teacher's handwriting on their completed problem saying, what 30? Where'd you get the 30? This shows where I got the 30, showing my steps. Okay, 30 squared happens to be 900, so we have 3.14 times 900, which is going to give me 2,826 inches squared. The area of the shaded area, the area of the shaded region is going to be 2,826 minus 314, which is 2,522 inches squared. Doug double checks. No, I have 2,512. Yes. See, it's a good thing I double checked. 2,512, not 2,522. And we see the dangers that are encountered by people who try to do math in their heads too often. 2,512 square inches is the answer. Not really a very wordy problem, but it was a multiple step problem, and it was fun. I hope that the students think it's fun. Okay, here's one that's weird. It's a weird shape, and I have to draw it. So, drawing the weird shape, I'm going to slow down and try to draw it well. I need to erase. Okay, I can erase all of this. Okay. I need a diameter. So, I need a line. So what I'm going to do is start by just drawing a straight line with this ruler. And I'll make the line longer than I think I need. There. And then I will use this handy little tool, which is really a protractor. I'll mark the center. And I'll draw a semicircle by tracing the bottom of this. So far so good. Can I do the rest of this drawing without making a big mess? It's going to be a bit of a freehand estimate. I am drawing another semicircle, but a much smaller one. And then I'm doing it again. Okay, finally, I'm going to get rid of this little extra bit because I didn't need it. Fix this. It's not perfectly drawn, but this diagram, where are my words? Oh, I did it again. I don't have any words. I was so busy doing the diagram and being happy with the question that I didn't really turn it into a word problem. But I'm going to say some words. Okay, so we have this weird shape. This weird shape is made from, and we really have to say this, we have to give the student fair amount of information, because looking at this and it not being drawn perfectly, we're not really sure what it is. But it's made from 3 semicircles. And what am I asking? Oh. And I have to give some more information. We need some diameter radius stuff, so I will add that to the diagram. What is the perimeter? What is the total area? Again, not very word problem-y, but it's a geometry word problem-y, and there's a diagram. So the diameter of this large semicircle, d equals 32, and this time we have centimeters. And then in both of the smaller semicircles, so I'm going to have to draw arrows, the radius is equal to 8 centimeters. Now, did I even have to say that? Because if that diameter is 32, I'd have to have wording in the paragraph that says that these are congruent. Now we know, since the arrow is pointing to both of them, they both have the same radius, that they are congruent. But if I don't give the information that way, I have to give the information in some way. Because what if this semicircle were slightly larger in radius than that one? Then it becomes impossible to solve unless you have the information. So I have given enough information now that we can answer this question. We are going to find the perimeter of this shape. Now, does that mean we're finding the circumference? Not of this shape, because this shape is not a circle. So it doesn't have a circumference. But the semicircle down here is half of a circumference of a circle. So we are going to use the circumference formula. And we will use the circumference formula for the small semicircles as well. It is actually a little bit tricky. You have to slow down and think about it carefully. But the circumferences of these are going to be useful as building blocks so that we can end up giving the perimeter of the weird shape. Weird shape. Okay, so I'm going to start going per circumference. This is a diameter, so I'm going to use c equals pi d for the large semicircle. Equals 3.14 times 32 equals, maybe I should just calculate it. It's 100.48. Yes, 100.48, and it was centimeters, and circumference is still centimeters, not square centimeters. So it's 100.48 centimeters. But that's the circumference of the circle that this semicircle is half of. But the other half isn't there. So I have to divide this by 2. And I get 50.24 centimeters. Okay, we have the length of this part. That is a portion of our perimeter. Now we have to find the length of this part and this part, which are going to be equal to each other. So we have to find one of them, and then we know that there are two like that. That's an interesting thing to think. We're basically thinking forwards and backwards and forwards again. I find this question fun. Okay, so the radius is 8, so I'm going to use the circumference equals 2 pi r formula, which is going to be 2 times 3.14 times 8, which is 16 times 3.14, which is 50.24. That's funny. We already have 50.24 up here. 50.24 centimeters. Now that's the circumference of the circle that this is a semicircle of, but there are 2 of them. So I could divide this by 2, and to get this little distance, this little semicircle half circumference, but then I'd have to double it again, because there are 2 of them. So I could say divided by 2 equals, and then times 2 equals, and get back to 50.24. The circumference of this circle, which is actually cut in half, and half of it's here and half of it's there, is 50.24, and that's what I need for my perimeter. My perimeter, what should I do here? I'm going to do it over here. Perimeter is equal to the 50.24 that's down here, plus the 50.24 that is the total of these 2. So the perimeter happens to be 100.48 centimeters. 100.48, again, 50.24. These numbers are just all over the place. Why is this happening? That's the fun of this, I think. Why is it happening? Why did that happen? Should we think we're wrong because that happened? No. We don't want to think we're wrong because something like that happened. We want to appreciate the beauty of it. It is beautiful. This diameter is 32, which means its radius would be 16. This radius is 8, which means its diameter would be 16. So the fact that we keep on getting these 16s that are associated with each other, 8 is half of 16, 16 is half of 32, this is why this is all happening. And if you just sit there and think about it, I find it very thought-provoking problem. And we still have to find the area, the total area. The area is going to be, and the same thing happened. You know how we had to do the circumference but for half of this, but then we doubled it, so we ended up using the whole circumference for these two. Doing the same thing with the area. Area is equal to pi r squared, which is 3.14 times 8 squared, which is 64 times 3.14, which will give me, where is it? Where'd it go? 200.96. And that is going to be centimeters squared. But that gives me the area of these two together. I don't have to divide it in half because there are two of them. It's happened again. But I also have to find the area of this bigger semicircle, and that I do have to cut in half. So area equals pi r squared, which is 3.14. Now the radius of that is going to be 16, and we're doing that thing where we're not showing a step. So over here, radius equals d over 2 equals 32, yes, over 2 equals 16 centimeters. Now I have it. Now I have justified that to show where I got that 16. 16 squared is 256. And 256 times 3.14 is 803.84. This is all fitting. Make sure that I'm not writing right off the rectangle of the video. 803.84. And that is an area, so it is centimeters squared. The total area, therefore, is 200.96 plus 803.84. Where am I going to put that? Here. I'll do it like this. 200.96 plus 803.84 equals, getting messier and messier, 1004.8. 1004.8 centimeters squared. And I managed to fit it. Imagine if I had tried to do this problem while that other diagram was still there in the way. I'm glad that I didn't try that. Okay, so we've gotten through another one. In fact, I've gotten through my whole first page, plus the mocha problem, and I only have 4 more. And that's okay, because I only have 17 minutes left. No, I've gotten through the whole page and the mocha problem, and the top one on this page, because that's the one that I had the diagram from. So there are only 3 more. Maybe this is doable. Okay, but the thing is I have some writing to do, so I did manage to actually create some word problems where there's some words to read, so I'm going to have to get busy and do some writing. Now, leaving the formulas, erasing all of this work that I just worked so hard to produce. Okay, Makiboo. Makiboo is a person. Makiboo's bike tire radius, I want to get way over here so that I can fit this. Makiboo. Bike tire radius. That's messy, whatever. Radius is 12 inches. And mine, comma, and mine is 15 inches. So you could guess that Makiboo is smaller than me. Makiboo is my granddaughter. And her name isn't Makiboo. It's a nickname. Her name is Michaela. So Michaela, who we know often as Makiboo, Her bike tire radius is 12 inches and mine is 15 inches. That's supposed to be the number 15. Let's make it look more like a 15. Okay, and I should put a period. If we each cycle until our tires have done 100 revolutions, woof! If we each cycle until our tires have done 100 revolutions. We have to talk about what's meant by the word revolution. So your bike wants a revolution. Hey, hey. Something like that. Okay. 100 revolutions, comma. How much farther than her will I go? Okay, so that's actually a word problem. And there's not even a diagram. In fact, I never even drew I'm not going to draw a diagram. Just to prove that it is possible to do this without a diagram and feel more word problem-y. But I would encourage any student who's trying to do a problem like this to draw a diagram if it helps you, because that's one of the things about that type of math, is when you draw a diagram you can figure out what to do better. Okay, so what is a revolution? A revolution is that's when the bike tire turns completely all the way around, so that the part that was touching the ground at the beginning has gotten back to, I'm going to do it like this. Okay, so I have where the 270 degrees is on this thing that's touching my finger, and if I roll this around until the 270 degrees is touching, again, that's what the bicycle wheel does. So if you were to put some chalk on part of your bicycle wheel that's right on the ground, and then roll the bike forward until the chalk touches the ground again, and then see how far apart the two bits of chalk are, the two marks are. Well, what you would have is the distance that the rubber on the bike tire covers in one revolution, turning completely around to back where it started, which would be equal to the circumference. So the circumference of a tire is very important for this type of problem. So we can figure out the circumference of both of these bicycle wheels because we know both of the radiuses. And then we can do the rest of the problem. So I think we need to get into the circumference of a circle formula. And we're using this version of it with the r, because in both cases we were not given the diameter, we were given the radius. So c equals 2 pi r equals 2 times 3.14 times Makibu's radius, which is 12, equals, where's the answers to all of this? 75.36. Use calculator, of course. And then the circumference of mine is also 2 pi r, which is 2 times 3.14 times 15, which is giving me 94.2. And both of these are in inches. So I'll put my inches symbol. We can see the difference in what happens with my bike compared to hers, because I have a larger bike. I have a larger bicycle wheel. Whenever I make my wheel go around once, I cover 94.2 inches, and she only covers 75.36 inches, which is why, after we do 100 revolutions, I will have gone farther than her in distance. So we have to multiply these numbers by 100. So I didn't really leave room very well for that, so I'll say for Makibu equals 7,536 inches. So multiplying a decimal number by 100 isn't that bad, right? 7,536. And then mine, I can more neatly put right here, 94.2 times 100 is 9,420 inches. So have we gotten to the answer to the question yet? How much farther than her will I go? Yes, we have. No, we haven't. I have to subtract. 9420 minus 75/36. Now, you might be asking, why are we using such big numbers? I have to touch. There, sorry, I had to touch the camera for a second there to tell it to stop worrying about something. 9420 minus 75/36 is equal to 1884. So I will have gone 1884 inches more than her, but inches, would we really give that answer in inches? It was convenient to do the calculations in inches because our radius was given in inches, but if we take this and divide by 12, what we get is, where is it? 157 feet. And that's a little bit more easy to understand. Thinking about 1884 inches is a little crazy. 157 feet, but I can also divide that by 3, and I get 52.3 yards. Okay, so which is the right answer? They're all right, because the question didn't say give your answer in yards or anything like that. I just felt like doing that. Now, I'm worried that I'm going to run out of battery on this, but there's only 9 minutes left in the lesson, and I only have 2 more word problems to do if I have time to do both of them. Maybe I will only be doing one. Okay, erasing all of the Maki-Boo answer, but I'm going to keep the question there for now because, oh, there's more to it. So let's call that A. I'll just put the A here. And then B. What is the rest of this problem? If we cycle 100 yards, so that's not the same, because that was, remember, 53.4 yards. This is different. We have a new situation. If we cycle 100 yards, how many more revolutions will her tire do compared to mine? How many more revolutions? It's the writing of the word problem that takes all the time. Will, messy, her tire do, is this even fitting? Yes, her tire do, and I guess I'll just put a question mark there, but I meant to say compared to mine. But that's implied, and we can answer this now. Okay, how are we going to do this? And will we have time to do it before the camera conks out from lack of charge? Well, we have to know how many inches are in 100 yards because we've been doing all of our calculations in inches. So 100 yards times 3 equals 300 feet. Not 330, 300 feet. And then 300 feet times 12 is equal to 3,600 inches. Not so bad. Okay, we got that far. Need more chalk. Well, need a completely new chalk because I finished that one. I did not need to run out of chalk at that moment. Okay, but I'm okay. Oh, okay, we have some division to do. 3,600 inches, which is the 100 yards that we are cycling, divided by the answer from before, which I guess I should have left on the chalkboard wall, divided by 75.36, which is the circumference of Maki-Boo's tire, equals 47.8 revolutions. I'll put revs. And messy looking R, revs, okay. And then 3,600, same distance, it's still 100 yards, divided by my 90, where is it? My 94.2. Where'd it go? I can't find anything. 94.2, yes. Equals 38.2 revolutions. So this time it's her. She did more revolutions. Yes, it makes sense because the circumference of her tire is shorter. So therefore, to do the 100 yards, her tire will have turned more times than mine. So she's the one who did more. 47.8 minus 38.2 equals a difference of 9.6 revolutions. 9.6 more revolutions. Well, you know. 9.6 more revolutions. How am I doing for time? That's it, I finished that one. I think what I'm going to do is I'm going to set up the next problem. And if I have time to finish it, I will. But if the camera looks like it's going to conk out, I'll just leave it as homework. Why not? And of course, anyone who comes to me later and says, wait, what was the answer to that last word problem that you didn't finish in the video? Well, I'll calculate the answer and I'll help that student. But I bet the students will be able to figure it out because it's really the same math and we're getting pretty good at this, aren't we? I can erase. Will I have time to write out at least the problem with a diagram before I run out of time or charge? I really don't have time to take a sip out of my fizzy water, but I'm doing it. Oh. Okay, this is going to be a weird one to draw. I'll try. This is a dining room table. It's round. That a lot of people needed to eat at during a family gathering at my house not that long ago. It's got, so I'm not really writing a paragraph, am I? It has a 40-inch diameter. 40-inch diameter. On it, we put dinner plates. Now, 40-inch diameter. The diameter of the dinner plates is 10 inch. It's not a very big dining room table. The diameter of the dinner plates is 10 inch. So I'll draw one of them. It's not perfectly drawn, I'm sure. And then I'll draw a second one. Okay. Diameter equals 10-inch plates. So the question here is, how many plates can we fit all the way around the edge of the circle of the table without the plates sticking, with the plates just going right up to the edge of the table? They're not sticking out over, that would be silly. But they're not also pushed into the center of the table because that would be a waste of space. So the way I'm drawing it is pretty good, except that these circles are not perfectly sized. How many plates are going to fit? Now we could estimate, I could just keep drawing and estimate, but that would be a very rough estimate because I didn't really make sure that the big circle was drawn proportionally to the smaller circle, respecting their diameters. Time. How many plates will fit? This is a bit tricky because what's stopping the plate is the next plate. The plates are touching each other, but we're not letting one plate, ride up over the top of another plate. So the diameter of the plate is kind of important. It's kind of would do this, wouldn't it? And there's the next one. So it's like I'm taking a bunch of straight lines because the diameters are straight lines and I'm connecting them together into what could be an octagon or another shape that has more sides than an octagon. It depends on how many plates will fit. It's kind of a cool question, even if it's not exactly a word problem because I don't see many words at all on here. How many plates will fit? How are we going to figure this out? I'm going to give one hint and then I'm going to stop because I'm running out of time and charge. The hint is we have to figure out that diameter is sort of halfway across the plate from the edge of the table. What is that distance? And we have to try to imagine maybe there's like a smaller circle that's going to have a smaller diameter than 40 inches, which is really going to be where all the middles of those plates touch each other. And that smaller circle is important. How do we figure out its size? And bonus points if you can tell me how much area of wood would be showing on the table after we arranged all of the plates that will fit. It's a good question. Okay, so with that, I am going to say thank you for being here. We are running out of time, and it has been fun like usual. Enjoy doing your homework. I am going to say goodbye. I'm going to make the dog with the perfectly round eyes, although she was asleep, so they may not be fully open, say goodbye along with me, and it is supper time for her. I am looking forward to next time. Circle geometry is fun. See you next time.